Hey, you're at Steve Morris Engines. I'm Steve, and I got something a little bit different for you. And actually, I'm kind of excited about it because it's pretty rare that I get to do anything specifically for myself. And so I'm going to show you an entire buildup of my own personal SMX engine. Now, this one isn't mine. This one's the customer's. So we're going to go right from the start of everything, and right from ground up of putting the cam bearings in it on up to the complete. And I thought maybe you guys would get like to see the complete engine buildup on something really cool. So anyways, we're gonna start it out right now. All right, and here is the platform of everything, the SMX block. So what I'll show you here is, first thing, I'll just go over everything because I don't think a lot of people really know what's going on, and most people wouldn't, honestly, so it's no big deal. So this is our block, obviously. Now this is water jacketed, solid billet, but this is endurance water jacketed, obviously. So let's just go right from the front. So this is a, it's 40 bore spacing. It has a Hemi front, basically a Hemi front, and then big block Chevrolet back. So I guess you could say that, okay? So as you can see here, the whole timing set, everything that's up through here. Now this is the block I've already just got done deburring it, clearancing it for stroke, just down at the bottom of the sleeves, making and finishing the cylinder bore and hone and notches. So you see here, there's a exhaust valve notch, and then up on this side, a little harder to see, right there. Oh boy, you can't hardly see it. Let's see. Is a intake valve notch, just right there. Intake valve notch. So you can see the deck height is 10-400. I use a 904 bearingless lifter in these combinations, and I could use a big keyway style lifter and do like a 937 or 1031 or 1100. I mean, there's a lot of different options there, but this works. I've proven it works. It's easier. I like the way it oils better because we are doing this for endurance. We are not doing it for any other application other than endurance and super high horsepower endurance. I just know it works and I kind of stick with it. Could something else work? Also, possible. That's possible. 4-500 bore. As you can see here, these are the receiver grooves for the cylinder head, for the fire ring, for the SMX hoops. So the fire ring goes in there. So all these things are all part of, if you wanted to see something on lifters, I explain lifters in my Steve Tech videos. I explain this whole hoop process, the SMX hoop, fire ring process, how that all works. So you can always go back and just see. So I'm just telling you what this is. I'm not going to re-explain everything that I've already done in a Steve Tech video. This is 65 millimeter core camshaft too. All right, so and it uses a Babbitt bearing currently. So Babbitt bearings 1 through 4, and then this is the rear cam bearing. So you use this rear cam bearing like right here because this starts, or I'm sorry, this also sets camshaft thrust. It's part of the thrust process in the rear journal. So I will, as we get into installing camshaft, I'll go over that with you. So I'm going to put the cam bearings in it here, oil galley plugs, and start the assembly. And as I'm going through it, I'll just go over every single thing through you. Now, what we see here too is, I'll start from water in, so you get a good explanation of water in. So this is covered by a plate, and water goes in right here. So water goes in the front of the block. There's a small transfer through the front that just cools the front side of this cylinder, and then has a bleed hole up through the exit, but there's not much going on there. Water comes in here, follows cylinder line, goes to the back of the block, transfers through the entire back, right through here, these holes, and then goes into the front, or into the lifter valley side through these holes, all right, which gets you into the lifter valley. So these water is gone across it back here, then goes right straight through all the way behind these welded plates. Now we're working on, the new block will be all bolted in plates. These versions were welded in plates, so we're working on new stuff there. And then water comes out here, all right, so, and it's the same on both sides. So water in here, goes around the outside, around the outside of the back, then comes up through the front, and then out right here. So each side of the block is completely separate. So there is water in, water out. On the other side of the block, there is water in, water out. So if you look over on this side, they are not combined. They're not touching each other. And there's no crossover. There's no crossover in the head, and there's no crossover in the block. Also notice that there is no water through the deck surface. The deck surface is no water transfer. That's why we need to have water in, water out, and then up on the head that I'll show you later is water in right here, water out right above it. And it does the exact same kind of watering through the cylinder head. I'll show you that as we get to the cylinder heads. So we've covered deck height. The main journal size is big block Chevrolet. Uses a Hemi pin, so the 2375 journal pin. I'll show you more things on the crankshaft as we get there. But this is the block. Bell housing patterns, a dual bell housing pattern for Chrysler Hemi and for big block Chevrolet. Obviously use it in big block Chevrolet. This is a lifter scavenge. If people wanted to scavenge out of the lifter valley, I give that option. Now, the way oiling system works, people need to always verify how oiling systems actually work. Oil goes into the block right here. So right on this front panel right here, we have different variations, different oil pumps. Oil comes up through this passage right here. So right there is our oil in. Comes up here, transfers to the main oil galley. Let me lower the camera down here just a little bit. Sorry about the camera work here. Here, I'll just take the camera off. So, as you can see, this is our main oil galley from the oil pump. Comes up here. Now this transfers through a hole right here. This is the main oil galley. This oil galley feeds all the main journals, which feeds crankshaft, obviously. Crosses over, feeds cam bearing, just like a traditional Chevrolet does. This also goes up and feeds this one lifter galley. Now, you'll always see in all of my SMX blocks, there is a oil feed hole here and an oil feed hole here, because this lifter valley is the only lifter valley that is pressure fed. There's nothing over here until we run a line, -6 line, from here over to here, and here over to there. So that is how we oil this lifter galley, and i.e. the cylinder head and all the valve train on this side. So oil comes up, reiterate, main galley, priority main oiling, goes up to the lifter galley. Lifter galley then crosses over from this lifter galley to the other lifter galley with a external line right here, right here. I feed it in the front and the back, so it has nice equal distribution, trying to not have low volume or low pressure spots in the oil galley. That is the block. Oh, now these sleeves too. Now I do these sleeves differently. This sleeve is this thick. This is not just a step. This step is actually 2 inches down into the cylinder. So this entire this entire high pressure area in the cylinder is thickest sleeve possible, and then go from about my finger down. The rest of it is normal thin sleeve. Now, as you can also see, there is nowhere in here on any of the block that the cylinder bore, except at the head bolt holes, has less than about 3/4 of an inch of material. So trying for maximum rigidity in the cylinder bore itself. Now, the other thing that you see is this. Well, let's backtrack. Wow, that's awesome. I'm gonna get that block and I'm gonna put my heads on it. No, you're not. Your heads aren't gonna fit on my block. The only heads that fit on my block are my cylinder heads, period. Because this head bolt hole right here is a totally different deal. Now this head bolt hole, I'll show you later in cylinder heads. This head bolt hole goes all the way down into a solid portion behind the lifter galley oil hole, into the block right here, and gives us a full 1/2 inch head stud, just like 1/2 inch head stud, 1/2 inch, 1/2 inch, 1/2 inch, 1/2 inch, 1/2 inch, instead of like the other version of the solid motors, and like a standard 481X type motor that would just have a small 3/8 bolt right here running up beside the intake port. This is a 1/2 inch head stud that runs through the center of the intake port. In fact, you have to take a cap out of the top of the intake port to access that head stud, which is at the floor of the intake port. So all really cool stuff. I'm very proud of this whole deal. Obviously all solid billet. This is the camshaft, or I'm sorry, the cam sink, so i.e. distributor. Obviously I don't run a distributor in it, but this is the cam sink / oil pump drive. So this oil pump drive goes all the way right down through there. So here's the gear, would be right here. I'll show you all that stuff. Goes through and drives an oil pump if we have a block mounted oil pump on it. Like I said, I have several different versions of oil pumps for these, depending on what you need. So anyways, that's the block, and I'll just do some slow motion or high speed photography on video on just putting the cam bearings in and starting the whole build process on this. Now here I'll stop and also show you, because I didn't show you the bottom end. So this is a splayed cap block instead of a cross bolted block. Look up yield strength versus shear strengths on fastening hardware, bolts, etc., and you'll see what I mean. And because what I do is this cap, like this. So this cap right here, these are billet aluminum. So this cap is spreading or pulling load from all the way right down here in this really super meaty part of this whole block versus just being cross bolted. Okay, versus just being a cross bolt through there. Cross bolts shear right off, right? This is actually pulling from the bulkhead area. So this angle split, or the splayed bolt, is going all the way down into this super high meat area right through there. So that's why I do that with these billet aluminum caps. Why do we use billet aluminum instead of steel? Because they're perfectly strong, they work perfectly well, they have the same expansion rate. I think that just is a better deal. And if you break this cap, you got far bigger problems than what a billet steel cap would have ever saved you. Now, one of the things you may be asking is, well, why don't you use a roller bearing, a drawn needle cup bearing for the camshaft, roller cam journals? Because we have that one, shoot, can't remember what it's called, what style bearing it has. Anyways, that one rear roller bearing that's in the back, and then would be able to use, and we are working on possibly doing it. But believe it or not, the Billet bearings, when they're running, when they have oil, there does not seem to be, and that could be wrong, but does not seem to be any direct advantage of friction when there's oil there. But I will tell you that a Billet bearing motor with big roller cam, big springs, versus a roller cam motor, roll over just cranking, or in the rollover, extremely lighter. Like by, like this engine will take about 130 pounds to roll over, about 120 to 130 pounds of torque to turn over, cold, not full, not pumped up with oil pressure, just like cranking. It'll be less than half of that with the roller bearing in there. But when this thing is running, and when it is running and there's an oil film there, they seem to be the same. So pretty interesting stuff. I am working on doing a roller bearing conversion for this, but there is no proper good bearing for 65 millimeter in the bore sizes I need, IDs I need, ODs I need, and width that I need. So I'm probably going to do a little bit of a camshaft change to use a common bearing so I don't have to reinvent the wheel. I don't like reinventing the wheel on stuff. So it's going to be something we're going to do, but only for the standpoint of doing a little more oil control. So oil control, they're great. Don't have any problem with them. They run them on drag week type stuff. They run great, but I'm always amazed at how this little skinny bearing with just oil pressure works, and works well. So anyways, just showing you that. So I'll grab a camshaft, and we're going to just test fit the camshaft in there. After we test fit it, then we'll start on the crankshaft stuff. Now this is that 65 millimeter camshaft that I was talking about. Now if you want to know more about this camshaft, actually you can go on my camshaft videos on Steve Tech. See the small journal up on top there. There you go, small journal for that big roller bearing, Billet, 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 Billet. And then this is the whole nose front with distributor gear for turning the fuel pump slash cam sync and all that good stuff, and the timing gear, which sets the other side of thrust. So that roller bearing in the back sets reverse thrust, and the bearing that's going to be in the front that I'll show you here later is going to set the front thrust on the camshaft.